welcome everyone to FutureNet. The panel discussion we're going to have is called Looking Back and Looking Forward. Now, for those that are Harry Potter fans, I don't want to disappoint. I don't think any of our panelists actually have magical powers. But we are really fortunate to have some of the strongest thought leaders in the industry from many different companies. And so together we're going to talk about predictions. We're going to revisit predictions that were made in the past. We're going to make new predictions about the future and really try to get our arms around what's happening in networking and where is the innovation going to lie. Because I'll argue that the imperative for change is greater than it's ever been. The combination of work from home and the sort of dramatic shift that we've all experienced during the pandemic, the steady onset of cloud and mobilization, it's driving a need for a different approach and philosophy to networking. And so I think some really interesting patterns will emerge from this conversation. So let me introduce our panelists. We have Bikash Koley from Google, Nick McKeown, who is a professor at Stanford, Vijoy Pandey from Cisco, Pere Monclus from VMware, and Albert Greenberg from Microsoft. And with that, I'm going to turn over to Bikash, and let's talk about Bikash. Could you make your 3 predictions for the future of networking?
Thank you very much, Tom, for inviting me back to FutureNet again. I take that as at least one indication that my predictions last year were not that off base. And I must say,
that's right. Based on your predictions, you got an invitation to come back.
Yeah,
so
absolutely. Yes. And it is truly an honor to be among some of the best minds in networking that are present today and some of my very good friends. So with that, I'm going to jump into my 3 predictions this year. The first one, by the way, is a slightly refined version of my last year's prediction because I think it still holds true. Networking will graduate from automated to autonomous. Now, what do I mean by that? I do think that networking has made tremendous progress in the last several years in becoming intent-driven and automated. The network that I happen to oversee, we hardly configure any elements or subsystems anymore. We mostly describe the intended network behavior, and the software system underneath ensures that the observed state and the intended state in the network are mostly consistent most of the time. Whether it's our SDN B4 or the SD-WAN product that many of you are developing, or even the modern campus and security products that many of you are developing, they're mostly intent-driven and automated. So a lot of progress. Now, I do think that all this progress has set up us for what's the next step in networking, which is really autonomous network. I think the network is going to learn good operational state through techniques such as supervised learning and reinforced learning, and it will act on its own when the observed behavior of the network deviates from that known good state. And it will either be a preventive step so that no outage happens in the network, or it's going to be fast mitigation. In both cases, the goal is really get the mean time to repair to as close to zero as really possible, right? Similarly, I also believe that an autonomous network will detect change in demand pattern. And the best example of that is the year-long pandemic, where many of us have seen the traffic pattern to completely change in our network with things like Google Meet, Zoom, Microsoft Teams. The video conferencing has really changed the traffic pattern that we see. And I expect that the autonomous network is going to auto-scale. Now, if it is a software infrastructure, that would mean that it would allow more software resources to actually carry this network load. And if it's a physical infrastructure, it would actually trigger workflows all the way from forecasting to planning to augmentation. And a lot of it is going to be physical work at the end of the day, but the automation is still going to trigger this work as that happens. So I believe very strongly that we are one step away from graduating from automated to autonomous in networking. That brings me to the second prediction of this year. I believe that networking is going to be zero trust. Now, if you look at today's network, it's actually a patchwork of policy, enforcement, and trust model that, frankly, it doesn't really work anymore. The old model of perimeter security is just not enough because, frankly, in the world of multi-cloud and hybrid cloud, the whole definition of perimeter has completely changed. And some of the recent attacks are the best examples where if an attacker is able to breach the perimeter, they have open access to most privileged information that a company might have, right? So I believe very strongly that zero trust has to be the basis of any network security for all application to application and user to application communications, where both users and applications now run in various different environment, right? So identity-aware proxy, end-user context-based policy and enforcement, and frankly, user and application level enforcement is going to be absolutely critical as we move into the network of the future. At Google, we have been on this journey for a while. If you have heard of our Beyond Prod architecture for really securing our application to application communications, or Beyond Corp for user to application communications, these are good examples of where I think we're going to see the architecture for network and security to really evolve going forward as the network matures, right? Third prediction, if we can talk of cloud, in today's world, we're actually not talking about the whole infrastructure, obviously. I do believe that networking will be cloud native, and access networks and security will get delivered from edge cloud. Now, what do I mean by that? First, cloud native. I do believe that really modular, containerized, microservice-based implementation of control and management plane for networking is going to become the norm for a couple of very important reasons. This implementation allows one to have infrastructure as code and config as data, irrespective of whether the underlying network is physical or virtual. And having infrastructure as code and config as data allows us to use some very well-proven tools, such as formal verification, progressive rollout, simulation and emulation before rolling some changes out in the infrastructure. It just makes our infrastructure a lot more robust and scalable. Second, I believe that network will increasingly be a cloud-native service that is delivered as SaaS. Just as compute and storage are increasingly consumed as service, networking will be consumed the same way. And that really brings me to the last point about cloud native. I do think that edge cloud is going to play a very important role in the move of network as a service. I believe all forms of access, be it 5G or the next iteration of 5G as mobility grows, SD-WAN for enterprises, hybrid connectivity, the next gen VPN, they will all be delivered from edge cloud. And really cloud as a whole will provide the global software-defined connectivity fabric as a service. Now at Google, we've already started seeing quite a bit of this. For example, we're working with some very large telecom operators that are already trialing running their 5G packet core from our edge location. I mean, it's just one example of how I think edge cloud is going to be key to delivering access. Similarly, edge cloud is going to be absolutely critical to how security gets delivered. We protect and defend our users against some of the largest DDoS in the world by really leveraging our edge cloud and the application front end that we have deployed around the world in our edge cloud. A very recent example, 2017, we defended against a 2.5 terabit of DDoS attack originating from, frankly, a nation-state actor. And the only reason that we're able to really, mitigate this massive DDoS was because of the distributed nature of our edge, and really preventing this attack from coming any further inside. Similarly, implementation like Beyond Corp, it uses application proxies at these edges to really implement the policy and the security. So, in summary, cloud native and edge cloud-based delivery of networking and security is going to be the norm going forward in the future. And those are my three predictions, and time will tell how true they are, but I strongly believe that that's where we're going with networking.
We have a good track record from last year's predictions, so thanks for that. And as you were talking, your comments about autonomy made me realize each one of us on this panel has probably been involved in building networking products, but also consumer of networking products. And what's the one thing we want from our networks? What's the one attribute that, universally, we want it to work, right? That's the most important thing. I want the network to work, and then all the other stuff kind of falls along. And I thought your comment about autonomy was really kind of the next level of that. Let's make sure that it works in changing conditions, not just in static conditions. I want to pick on Albert. Albert, what did you think about Bikash's predictions?
Yeah, thanks, Bikash. It was a great talk. I agree with all that Bikash said about zero trust and cloud native, and Azure has edge zones and 5G effort that's along the same lines, and I don't think there's much to rebut there. I want to talk more about the automated versus autonomy. I don't really want my network to be learning in production. I want my network to be learning in test and emulation. I want emergent behavior to surface early, and then I want to make sure that the emergent behavior is handled well. So I kind of want to shift left in time, the learning, and when I learn something, I really want to understand it. I want a proof that something kicked in because the mechanism that was anticipated by the engineers worked out. So this could be consistent with what you're saying or part of what you're saying, but I don't want some massive learning going on with some emergent behavior that to happen, even if it's ultimately good. I'd prefer to see that happen in a simulator, in an emulator, in a test bed. Thanks.
If I may pile on too on that same note, I was kind of thinking something along similar lines, and that is that we normally use learning and machine learning in its various forms for things that we don't really understand, right? Things for which we don't really understand their structure. So speech recognition and all sorts of things where it's been incredibly useful. But in networks, although they feel very complicated, they do relatively small number of things. And so it would feel to me as though good models that are derived from the intent would be a better thing to check against in a deterministic fashion against the original intent, both of the designer and developer, but of whoever is telling the network what it should do, should be our starting point, and then testing against that. And again, a little bit like Albert was saying, it feels as though that should be more deterministic than is typical of a sort of a learning model.
I mean, Nick and Albert, both great points. I wish that were completely true. And the reason being that there are so many different control loops that are running, not just on the network, but at the application layer, that when something goes wrong, accurately root causing is often quite complicated. One other very important thing with reinforced learning that I want to point out, it's how do you take a knowledge from an event that happens in the network, and let's say it's an outage, and you propagate the knowledge into improving how your network behaves, going forward. Again, an example is you can get one driver to get very good at driving. It's not easy to translate that knowledge into another driver because that driver could be doing the same thing. With reinforced learning, what you're learning from your one outage, you basically propagate into the next generation of the design in sort of a software based way, right? So that's the other benefit that we see in that approach. But great points, thank you.
Yeah, just to add to that, I think also, there are lots of control loops, but also there are lots of deployment patterns, and I think something like an Azure or a Google, I think the deployment patterns are getting simplified, and that's a good thing. But out in the wide open world, that's not always the case. And so running some things in lab and deciding on that, it might be a good way to canary test something and then move it in production, but production does look very, very different and very specific to what the customer's use cases might be.
Yeah, I just want to jump in. I think you can do amazing things in learning early. In learning in emulators and simulators and in models. So it's not that, some things don't fall through the net, but you want to make those things as few as possible. And you want that to be the exception. And really what you want to say is, I learned that before I deployed. And therefore, when it happened in production, no problem.
Yes, I would agree that I would much rather simulate outages in a simulator than simulate outage in the production network and then learn from that in the supervised learning model. So, Albert, I agree with that point. We should be shifting left.
Maybe taking on Vijoy's point, because you always think in terms of what does it mean to take a network, control it, learn. But when you start thinking the zero trust argument that you were making, right? You may have, let's say, a financial institution that have consumers that they are out of the scope of your network. They connect through a browser. And you may have employees that may have an agent, and they go through the internet to connect to your services. And then you may have multi-cloud services. So the meaning of networking right now is much more broad. It's not just a network that you control, that you can learn, that you can predict, that you can remediate, but rather it's a collection of elements that you have to go through. And as again, from an identity, from a network level, IP addresses, certificates, authentication, authorization. And it's not always as simple as like a model that you have a well-defined data set that you can react. So how do you view your ideas when you take it beyond the networks of Google and you take it to the wide world and you have to solve like a more scale or planetary scale problems?
Yeah, great question, Pere. Absolutely, learning the application level behavior where you can is critically important. We have done some of this with, if you go back to our work with Espresso, where we actually make traffic steering decision based on what we see in a YouTube session from a user, right? You can only do this if it's your application. Increasingly in cloud, that's not the case. It's actually somebody else's application where you have no visibility into what the applications are seeing. And that is actually partly why, I go back to why supervised learning and reinforced learning is important, because it's becoming more of a black box than it has been in the past.
Well, let me share an observation with our audience. We've gone to some trouble to create a production environment that allows a fluid and natural exchange among these thought leaders, and boy, has it disappointed. This is exactly what I was hoping for. So why don't we shift gears after that good discussion, and I'll turn it over to Nick. Nick, you also had predictions from last year. I'd love to hear an update. What's your forecast?
Yeah, sure. Thanks for inviting me back. I've also, like Bikash, have kind of evolved and morphed the predictions. But I wanted to start by just pointing out something we all know, and that's the way that we build and operate networks has changed a huge amount over the last 10 years or so. I mean, much more than they did in the 10 or 20 years before that. And I really wanted to sort of call out and sort of point out three changes, because I think it tells us a little bit about where we're going and informs the predictions. The first one is a sort of a change of who is in control. And everyone that's on this panel has been part of driving that change of who is in control. Before, networks were built from sort of closed and proprietary boxes, with tens, hundreds of millions of lines of source code, and they were running hundreds of protocols. They were bloated, they were power hungry, and there was really little incentive to improve them. And people talked about there being a stranglehold by the equipment vendors over those who were trying to operate networks, who then just found them hard to manage, unreliable, hard to secure, and very hard to scale. And scale was what it was all about, and that's really a big topic of what we're talking about today. And so the large network owners and operators, typified by the folks here, particularly the big data center companies, they started to build their own equipment. And we know how that went. White box switches, software that they wrote themselves, software that they downloaded and modified, homegrown software that was sort of often Linux-based. And while it's true that they saved money, it was control that they were after. And they brought their armies of software developers to bear on this problem. And while we know the sort of the SDN and OpenFlow and all these things, it wasn't it was really about bringing to bear that taking of control. And so I think this is going to continue to drive in the future. And so this is sort of the basis of much of the predictions that I want to make. And the second change is one that has been a bit closer to my heart, is that more recently that taking of control has gone down into the forwarding plane to control how packets are processed, whether it's in a switch or a base station or an access point, really modifying it, because if you want to differentiate, you need to change the way in which the packets are processed. And this has largely been done through various types of programmability, whether it's eBPF in the kernel or P4 or similar languages into the silicon and the ASICs. The third big change, which I think is also driving a lot of the dynamic here, is the move towards open source. Open source has reemerged in networking as a very legitimate and trustworthy way to build and manage and control large networks. It was like that in the early days, and then somehow with the rise of standardization and protocols and big vendors, open source got kind of brushed aside. And it's reemerged really because it's proved itself through Linux, Mozilla, Apache, and other big open source systems. And so now it's reemerged through things like Open vSwitch, Sonic, ONOS, a whole variety of. I used to keep track of the open source control projects that were going on. I can't keep track of them anymore, and so time and again, people have been able to show that if you have open source and you have a lot of eyes on it, a lot of people whose networks depend on it, then they will make it better. They will make it more reliable. And I think that Albert's experience with Sonic really bears this out. So based on this, what happens next? I really want to sort of say how I think this shapes and informs what we're going to do in the future. And I really kind of put it down into three things that you can see here. One is that networks, for the first time, I believe, will be programmable top to bottom because the owner and operator is in control of that software. End to end, because they'll start to shape the way that they process packets from user space through the kernel, through the NICs, through the switches, all the way from end to end. And that this will be defined entirely by software. All of these things really change how we will build networks in future. It also opens up some amazing new possibilities. If everything is defined in software, it's not just a small change. It's because everything is in software, we can bring to bear software engineering techniques, formal verification, learning, as Bikash was suggesting too. But actually, it's in the formal verification, those tools and techniques that we haven't really been able to borrow from computer systems until recently, that we can now bring to bear here. As we have multiple layers of abstraction, testing and verifying across those layers of abstraction will bring in, I think, exciting opportunities for formally verifying, checking, and validating the behavior of networks, and then closing the loop to actually fix them when they break. And hopefully that'll be mostly of formal models and specifications, but where we need it through learning and observed behaviors. Now, one thing that really is changing that is different in my perspective from last year is, 5G is being defined in software too, whether it's cloud managed or out at the edge or disaggregated base stations. And because of all of the emphasis on the where your software came from for your 5G network, which is a sort of big political hot potato at the moment, it means that 5G, I think, is going to be dominated by open source and cloud managed edge solutions as well. And this really opens up a whole load of possibilities and a whole load of changes. One of them is that 5G starts to look like the rest of the network, so that the cellular network starts to be controlled and behave. It just becomes part of the network that we use every day, much more so than it has in prior generations. So all of this leads, I think, to the network feeling like a programmable platform. That was one of the things I suggested last time, but I really believe this more passionately and more strongly now. We will define the behavior at the top. It will be partition compiled and delivered into processing elements and forwarding elements throughout the network. Second, I think that networks will be deeply programmable. Those who own and operate networks will decide what they look at, the dials that they can see and the knobs that they can turn, so that they can best control them as they need to. Third, I think we'll no longer think in terms of protocols, we'll think in terms of software. It will be finally that the software is lifted up and out of the hardware, and the protocols will be turned into just software programs that we write. And fourth, that this deep programmability and coupled with a very fine-grained visibility that we're starting to see through telemetry means that networks are going to be under closed-loop control. And that is big. That's, I think, the way in which we'll deliver that autonomy that Bikash was referring to. And in the end, I'll go with the same soundbite that I did last year, which is I think the networks will be programmed by many, and it will allow us to have them operated by very few, which is what it's all about.
Great. Always enjoy your predictions. Let me ask you, when you talked about control and even programmability, are you inferring simplicity? Is that part of your thesis? Can we simplify networks?
One thing that I've sort of observed over the last 10 or 15 years as disaggregation data centers, different operators struggle with what parts of the network to take more control over, what software to write for themselves, what to share and borrow from others, is that the common theme is the boiling it down to the essence. The typical backbone wide area router today is based on like 150 million lines of source code. And that's because it has to support every single possible protocol that's ever existed, because that's what a customer may be supporting. Most data centers, they may have 3 or 4 at most. But they're different from each other because they're differentiating or they're targeting different sets of workload. And so they boil it down to a very few that they need. So I think simplicity is happening. And I think that's what you do when you have control over a system that you're trying to make reliable, secure, and scale, is that you keep it as simple as possible.
Yeah, interesting. Now, both Vijoy and I live in the reality of the enterprise where you've got this jumble of legacy things and boxes of different flavors and vintage and whatnot, and it makes it hard to simplify. So Vijoy, I'll pick on you. If you could maybe share your reactions to Nick's predictions, and then we'll just open up to the whole group.
Yeah, I mean, I think awesome predictions first and foremost. I mean, I think I'm looking at all of these predictions as challenges for us to solve rather than predictions themselves. I mean, we are here, we are networking people, and we would like to solve these challenges for the industry, for the community. So on the programmability side, I think the one thing that I'm curious about is it's awesome to make silicon programmable, out of box programmable. Who is the consumer of that programmability? Is it somebody who's writing or building out data centers, or is it somebody higher up the stack? And just as a corollary, and just to maybe push it a little bit further, if we want to raise it a little bit higher and say that maybe application developers can program it, how can we make it easy? Because it's not very easy to comprehend networking silicon in the same way that you comprehend general purpose silicon.
I do think that that will be opened up slightly more when we start to think of how we can introduce more offloading of computation to streamline that computation. So think of machine learning training, where you want to do aggregation of parameters in the network. That's best done in the forwarding plane. And we're beginning to see some examples of that. And now you need to bring in people that have a different kind of programming experience. And so you've got to make it approachable and easy for them to do that. So I think that will steadily happen over time. I don't think it's ever going to be the case. Well, maybe I shouldn't say this. I think it may be a long time before our undergraduates are going to be, instead of just sort of writing their JSON code or their new applications, that they're actually going to be off changing the forwarding behavior of their network. Maybe they will, I don't know. But but before we reach such a broad audience as that, I think we have a long way to go.
I think maybe I would mostly agree, slightly disagree. I think the real problem is that networking is yet to have clean abstractions actually defined in open source, if we can, and clean layering. Yes, there has been OSI 7 layer that has described it for a long period of time. I mean, there is a different set of layering that is necessary. I mean, I can completely see how an application would want to change a forwarding behavior in a switch, but the application shouldn't have to know that they're changing forwarding behavior in a switch.
Yeah, I know. I think you're absolutely right. I mean, I think we've come quite a long way. If we were having this discussion 10 years ago, I bet you someone would talk about the format of a packet header at some point.
Actually, I have one more comment here, and this is not just for Nick, but for the broader group here as well. So we talk about fine-grained telemetry, and we talk about gathering stats and logs and so on and so forth, and it's absolutely needed. Not everybody is a Google or a Microsoft or an AWS. So that deluge of data and how you handle that data and drive some sort of insight from it is actually a real big problem for a lot of our customers. And I think, how should we simplify that? Because it's absolutely needed. And we went from a spigot, which was SNMP, to a fire hose with streaming. And then how do you make sense of it all?
And if you take the analogy of what's going on in the electrical industry, for example, when you think about the electrical grid, is a network too. You have to route power, you have to make it drive to multiple destinations. But imagine that now the applications would code against the electrical grid, and I would say, I want more power, I want less power. So that potentially could disrupt other applications. So I'm a little bit with what Nick is saying, networks will be operated by few, programmed by many, but When we think in terms of programming, it's probably about expressing more capabilities in terms of how to discover SLA, how to self-remediate, how to provide telemetry, how to do things like that, because the notion of applications messing up with the shared media, it's complicated by definition, right? So probably we have to start thinking in terms of how applications share a common media, and this is how some of the early principles with TCP and control loops and things like that were designed. But we have to always remember kind of like the end-to-end aspect of the endpoints, and then the communication elements. And then the communication elements probably is the more automated, the better. And in order to do that, we will have to program and learn new techniques and bring new automation to make it happen.
Yeah, no, I think this is a good point. You're just going through this sort of this change in the way that the sorts of things that we measure. It used to be that you would sample things every now and again, and of course you miss the things that happen in short time scale. To moving to, hey, look, the switches and the routers, they knew all along the path that the packets took, how long they delayed, whether they were dropped, all of these things. Hey, why do you put it in the packets and ship that along? But then you end up with this fire hose that you're talking about. How do you deal with that? So I think the step beyond that is to say, not how do we reduce the amount of information that we're collecting, because then we go back to where we were before. It's how do you introduce ways of sort of triggering and filtering and looking for events closer to the forwarding plane of your network, so you can do it in real time.
I want to ask a question to the whole group. So the vision of automation is based on abstraction and standardization, right, Nick? That was sort of what I heard you say. And so I'll argue that Sonic is a sort of really, really important development and on that journey. But I think OpenConfig is an even more important development. Accept, reject, refute. Am I wrong? Do we love OpenConfig? Is that the future? What do you think?
Well, I mean, for someone who actually saw the...
Bikash is not allowed to answer that question, but that's okay.
This is a technical conversation, not marketing.
I'd love to hear from Vijoy as well. But yes, for someone who saw the birth of OpenConfig, I do feel that it actually, going back to the layering, I do feel that it is trying to solve, it hasn't solved yet. It is trying to solve a very important layer of programming that has been underinvested in both open source and open API throughout, and it is as important for physical as it is for virtual. And extensibility was a key goal of the whole design of OpenConfig, because when we were designing it, we actually had no clue what all it can be used for. And so it gives a real easy way of, for example, today we have firewalls that we configure with OpenConfig. We have Wi-Fi access points that are configured with OpenConfig, right? So yeah, I mean, of course, I'm biased, but I feel pretty strongly that it's a very important open source development for the industry.
No, man, I've lived the same pain points in the past, so I'm a believer as well. So I'm not the right person to answer this. I think it's the right level of abstraction and extensibility to move things, especially in it is a multi-vendor environment. Let's be honest. So I think in such environments for the operator, it just provides a good layer of abstraction to configure a wide variety of vendors, devices, roles, etc. So I'm a believer.
But doesn't it inherently commoditize, a switch?
Yeah, I don't think it's commoditization really. I think it's standardization of the interface, right? So we could use the example of one can use P4 to describe their switching ASIC, but there is still lots of room to innovate within that description, right? Because not all switches or NPUs or NICs are going to be the same. It's the same thing here, right? That it provides standardization, which is actually a good thing, because it allows somebody to start, especially someone who's starting from scratch. They actually know where to start, which was not the case before. Like they have to come up with Vijoy, no pun intended, Cisco-like CLI. That was their baseline, right? In starting a management plan definition, which is not the case anymore, right? They actually know.
Been there, done that before Cisco.
Exactly. So I think it provides a pretty decent starting point for somebody to start with a programmable management plan design for any sort of networking, whether it's physical or virtual.
Could I make a few points about the open source stuff? I think you have to look at what problem you're trying to solve and what community you're trying to empower. When it comes to, like Nick pointed out, Sonic, you're trying to solve a quality problem and a control problem, but you're also trying to solve a supply chain problem. You want to be able to consume these amazing ASICs and optics and what have you, networking gear from the fantastic industry that we have. So it's not the direct thing, but you're opening up or you're empowering a larger community, and a lot of people are benefiting from it. And I can tell you, like if you ask, what else can tower on top of that base? Well, there's all the middle boxes and the security products and so forth. So it's whether an open source or an open anything takes off or not depends on community, and are you empowering that community or not?
This conversation doesn't disappoint. So let's shift gears, and we'll pass the mic to Vijoy, and you can talk about your projections for the future.
Thank you, Tom. Again, it's a pleasure to be here again, and unfortunately, we're not there physically where we can actually have a much more heated discussion. We can wave our hands around much better, but this is the next best thing. And my predictions are also very similar to what I had a year ago. They're extensions to what we had a year ago, but I've also added a whole bunch of other predictions in the mix, because we've seen an evolution over the past year around a whole bunch of these aspects. And I'm trying to raise the problem statement a little bit higher. Like I mentioned earlier, these are almost challenges that we as the community need to solve for. And I think we need to move that challenge bar a little bit higher up the stack. So where I want to start with is, what is it that we are all here for? And in the end is to make sure that the application experience is awesome for the customers of the app producer. Because in the end, the application experience defines your brand. So let's take an example. I mean, you might have an app which does loan disbursement. And so I come in and I'm looking for a loan, and I go to a banking app which says, plug in your numbers, plug in your information, plug in your social security, and right there and then on the app, I'm told that your loan is approved. Versus I take another app which says, plug in your information, bank information, social security numbers, etc., and then they say, call this number, your application has been saved, call this number, talk to an agent, and they'll walk you through the rest of the process. Guess which one you're going to pick? And if you're like my teenage daughter, you will absolutely pick the one where you don't have to talk to any human being on the planet, and you can do everything from that phone screen. So that actually defines which customers are going, which providers of application or banking experience are going to be successful versus which are not. And so if you are a developer of that application, if you are trying to get those features out, faster features, better scale, higher security for that banking application, for that loan application, then your goal is to run fast. And if you're doing that, you want to pick and choose APIs which make your life easier and faster, and really not worry about infrastructure and scaling and security. And when I say you don't need to worry about it, it's not that I don't care about it, but I want somebody else to worry about it. So you don't want to worry about it, you want somebody else to worry about it. So I want to just pick and choose the APIs that matter to me for that loan/banking app. But unfortunately, you have to also deal with brownfield environments. You need to deal with on-prem environments, because Vijoy is looking for a loan. He might go into a bank branch and just withdraw all the money in the bank, and then poof, you're out of luck. So you need to be able to interface with what's happening at your branch offices. In this case, what's happening in your probably mainframes that's sitting inside your bank. And you're dealing with APIs not just from cloud providers, but also from various SaaS providers. So it's a pretty mixed brownfield environment. And then while I'm building out this app, I want to use the same pipeline, and this is to Bikash's earlier point, for code, for infrastructure config, for security, everything through declarative models, push it down, fire and forget. I mean, that's the way you want to operate all the way from the app all the way down. So in this kind of a scenario, there are three things that I think we need to do. And those are my three predictions. First and foremost, the APIs that this developer is using is actually going to be numerous, heterogeneous, and scattered everywhere physically. It could be SFDC, it could be Workday, it could be Google Cloud, Azure, anywhere. It could be on-prem, branch offices. These APIs are actually everywhere and scattered physically everywhere. So in this kind of environment, if I want simplicity, prediction number one is that all networking and security services have to be delivered and will be delivered through a SaaS model. That's going to be a no-brainer. I mean, there's nothing that's going to be non-SaaS moving forward. Now, if you raise your abstraction layer higher and go higher up the stack, and you look at the service graph that these applications have, especially in a cloud-native environment, the networking and security challenge is actually much worse in the service graph, because now you're dealing with microservices or serverless components that are talking to each other over a wide open internet. And in this kind of environment, again, you're doing service discovery, you're doing consistency across policies, across consumption of these APIs, and you're trying to connect all of these APIs and the data flow between these APIs with velocity so that you can move fast, and you don't want to interface. Unfortunately, you don't want to interface with the various silos that might exist in your organization, whether they are networking silos or IT ops silos or even cloud provider silos. I mean, that's a whole bunch of emails and tickets and calling that you don't want to deal with. So again, what you want to do as a developer is extend the application intent and just push it down. So prediction number two is that nobody is going to configure networking in the future, but only configure applications. And I'll basically point back to what Nick and Bikash have been saying so far is get that stuff going quickly, because we want autonomous networks, programmable networks that take care of themselves, because the configuration challenge is actually going to move to the application layer. And that's where we should be solving our problems. So that's prediction number two. Prediction number three revolves around security and perimeters. And I think Bikash touched upon this a little bit. But in this cloud native environment, the wide open internet, when you're dealing with all of these APIs scattered everywhere, the wide open internet is actually the runtime for all of these applications. So the security perimeter is actually getting very, very diffuse. It's actually getting to the point of an API to API call or an API to a data object call. So as long as you can secure an API or a data object, you're good to go. Now, of course, you want defense in depth and you want to secure everything else that sits below, but that's the direction that we would want to move towards. And the same challenges apply here as well. The developer wants to move fast, use the APIs that he or she wants to use to build their application with velocity and with the capabilities that they want. But the CISOs and the security SREs are sitting there and thinking, do I even know how secure these APIs are? Can I build out a compliance report? I mean, there is no visibility, there's no reporting, and these teams are disconnected. So how can we, again, remove the friction as well as make sure that the developers are moving fast, but the visibility and compliance exists with the security teams to make this happen? And so prediction number three is that moving forward, no one is going to secure networks, but they're only going to secure APIs and data objects. So if we get 1, 2, and 3 done, then we can reach a place where all requirements and policies are declaratively defined at the application, and then they are pushed down to the infrastructure, and that'll make the developer immune to the changes that are happening in the tooling and the orchestration software that sits below them, because that keeps changing all the time, as well as the heterogeneity in the API ecosystem that exists.
So Vijoy, I love this notion of a huge number of APIs. It's essentially microservices or SaaS that is being picked on in a very agile way as we build applications out of lots of APIs and small bits of code that we get from numerous places. And it's a very exciting model because it lifts up that abstraction up to the next layer. And as you say, it allows us to stop thinking about the network in the way that we do today. The plumbing will take care of itself, and clearly that's where we want to be. There's a but, right? And the but is that if I'm building an application out of a bazillion different pieces that are all over the place, then how on earth do I even think about the security, the reliability?
Yeah, I think it's a good question. I think that's to some degree, that's exactly what's happening, Nick.
Is that because we don't have a proper terminology? Because basically you've been using the word of the application needs to program the network, and then what? The application doesn't perform as expected, and who's going to fix it? So the application developers will not have the expertise in order to go and troubleshoot the network, especially across these zero trust distributed multi-cloud environments. And maybe what we are missing is a set of terminologies. For example, we keep talking about how the physical network needs to move packets from point A to point B. But then as we get into your prediction about how applications become a more important component of the networking hierarchy, now there's this need of defining what does the application expect? And this is where you get into the notion of identities and service names and discovery. But if you think the network reacting to the application is more about how to measure a set of SLIs in a way that then you can decide what actions to perform. But in some cases, you're going to have a problem in the physical network. And there's no amount of APIs that an application developer can do that is going to fix that. So do you envision that the networks really disappear, or that now we start having personas like the infrastructure person, the platform, and the application developer? And we have to start thinking in terms of how's the responsibility of securing communications across all the layers in a more holistic way. But still, from an operations, remediation, troubleshooting, there's going to be some differences between what an application developer is capable of and what a platform owner or an infrastructure owner may be capable of.
So if you want to solve routing between autonomous systems, that's better kept at a layer below. And we went one direction earlier, like maybe a decade ago, where everything was being solved at the physical layer. And you try to make networks smart, and we try to push all kinds of functionality into the network. And that's what led to the complexity that we're talking about here. And now we're pivoting to the other side. I mean, we are saying, okay, let's make the network so dumb that we're solving everything at the application layer. And so you're reinventing the wheel in a whole bunch of problem statements or problem areas at the application layer, which may not be necessary. So I think defining those abstraction layers and the APIs between them, and this is where I think to Nick's point earlier, open source can play a massive role here, because people will pick what is simple and what works with scale. And I think using open source to define those interfaces and define those APIs is the way forward here.
A follow up on that, when you say we don't want to make the physical network now completely devoid of any capability, how do you factor this with what Bikash was saying before, right? End-to-end zero trust models. Let's assume that now we go to a model that because of like digital communications privacy, we get into a full encrypted end-to-end communications. Now, is every single switch or every single router going to perform a man-in-the-middle attack and terminate TLS, or the network will just be able to move packets from point A to point B?
So I think in that model, it would be, it'll be difficult to terminate stuff within the network and look at packets and flows within the network.
Well, I would claim, going back, that the network just doesn't have the context to actually provide security or implement policy in that world, right? Because Pere, to your point, the packets could be completely encrypted, or the endpoints could be outside of your network, and therefore you really don't have the context to apply the policy that you want to apply on the network. So in that case, it has to get pushed closer to the user and the applications, because that's where your context is. Like, I don't think there is any alternative to that model, honestly, if we want to secure. But I want to come back to a flip point of this, which is, the nicest thing about OSI 7-layer model, and it had a lot of weaknesses, but the nicest thing is that it allows you, the client-server model allows you to switch or route the largest aggregate that you can get away with, because that's the cheapest by definition.
Well, that is a good point, but I think what's happening is also, if you think about, again, to your point, I mean, there is the networks are operating at a statistical aggregate level of granularity, or lack of granularity for that matter. But if you think about the application developers, they are concerned about narrow and deep context. And they really don't care about what the other application is doing to the same network. So whereas the networking folks are looking at aggregate flows, the application folks are looking at this microservice to that microservice and what that behavior looks like. So there is a little bit of a tension there, to your point, because yes, we would want to do the cheapest way to route is the right thing to do at the physical layer. But for the application people, it's looking at just their world and their silo and trying to figure out what's happening in terms of routing just between the services that they've written or that they're trying to use. So there's a little bit of a conflict there, and in some cases it might resolve, in some places it might not.
So are we just saying that now we don't have networks anymore, we have interconnected systems, and the interconnect is just one of the additional components of those systems?
My favorite word is connectivity, not networking. So we have connectivity and not networks. But that's a very pedantic discussion.
Pere, I'll throw the mic to you. You are very much a believer in application level connectivity. You want to give us your predictions?
So, I mean, very much in sync with some of the concepts that Vijoy was putting, and maybe I'll add some color on that. Last year, my prediction was that we would be focusing on what applications are doing. And within this definition of what networking is from an application perspective, we would be evolving the meaning of what networking is. And in that, I was mentioning this idea that you have the infrastructure component of networking, where you think in terms of IP addresses, switches, routers, and so on. But if you take the stand that it's going to be an application-centric approach, then it's going to be much more different. It's going to be this notion of authentication, authorization, identity, end-to-end encryption, certificate management, and DNS naming, which essentially boils down to this notion that as we go higher and higher into the stack, into the application, what happens is that we start thinking in terms of communications more at the business level or at the human level. We think in terms of how individual A talks to individual B, and what do I need to have an identity and a discovery of the other entity that I want to talk to. And this is where I was going last year with my prediction, saying networking will change based on applications and the needs of applications to focus on identity, discovery, scale, and security. Now, the place where I didn't anticipate the rate of change that we've seen this year is this notion of saying that the same concepts apply not only to applications, but to users, going to the things that we were discussing. Like now, how do we focus not only on what's the SLO of an application and how do we automatically correct the network and the systems and so on, but rather how do we focus on user experience? And for example, I'm sitting at home right now with a network that is not that reliable. And we have to figure out how my interaction, not only with the network, but with the applications that sit on the other side, essentially produce an experience that is satisfactory for me and that the provider of that application can react and fix it. Now, if we think what happens when we start thinking users and apps distributed around the world and users working from home locations, remote locations, IoT devices, what happens is that we lose control. And going back to some of Bikash's points in terms of what is the network? What is the context? Is it really in the network, or is it in the endpoints, or is it in the combination of both of them? And then when we get into this notion of saying, what is identity? Is it a DHCP service giving an IP address to an endpoint, or is it a certificate manager giving a certificate to an endpoint, or is it the user credentials to authenticate to a service? And when we think it like that, is all of above. I mean, all the previous ones. So my predictions are more towards saying that the meaning and understanding of networking and some of the OSI layers that we were discussing before is that the common denominator that many years ago was the IP layer, and we were using IP for identity and routing or location, is going to go one level up, or has gone already one level up, which essentially is at the HTTPS level. And maybe we'll have some other protocols for low power device and QTT with the TLS, but essentially we are at the TLS level as the common denominator, which this brings that now the network can only react to congestion, to destination rates and so on, but is less capable of seeing what's going on. And this is where we go to Bikash's point of zero trust and endpoints. So security models are going to shift towards an understanding of endpoint, application endpoint, and user endpoint. And this challenges all the current thinking in terms of separation of duties between the policy enforcement points and the entities that we are trying to protect. And as a collective, we'll have to essentially start challenging our own organizations in terms of how do we manage that. So basically, this jumps into prediction number 2, which is this notion of security, it's all of us. Connectivity, it's all of us. Doesn't matter if you're a developer thinking in terms of how an application is going to expose an API, or you are a platform owner thinking on how you rotate a certificate or how you monitor an SLO, or you are a network practitioner thinking how do my packets get delivered to the endpoint. It's going to be upon all these organizations to collaborate to be able to deliver secure solutions across the internet and across the user and app continuum. And the third one is going to be this notion that when we get to that, to Vijoy's point, which I completely agree with his name, is we will stop thinking networking. We'll start thinking communications. And the moment we think communications, we take a much more holistic understanding of the problem, where it's not that a network is a network because it has a cable and a port, but rather communications is, I need to understand who am I talking to. I need to discover this person. I need to understand their experience and my experience, and I need to have it in a secure manner. So the third prediction is this, that what Vijoy was saying, that maybe a pedantic conversation, I think it's going to become mainstream. Everybody's going to talk about secure communications rather than network transport, because this is at the human scale of what we are seeing in terms of the way we will work and the way IoT devices and edge components will interact with applications in the data center or in the cloud, is going to force us to think this way.
Nice. So APIs connected by encrypted connections creates a whole new networking paradigm. Nick, maybe I'll throw the mic to you to react to Pere's comments.
Sure. Yeah. I mean, it's some of the things that were going through my head where you were describing that, which it's sort of as an aspiration, as a sort of a dream for how networking will be, and as an observer of how it's been going, quite recently. I agree. Similar worries to what Vijoy was coming from, what Vijoy was saying, and that is, I think we tend to, as we put in place these higher level abstractions, and I agree, we're moving up in those level of abstractions, but those abstractions are more about control and abstractions of how we view the network. But I think we mustn't lose sight of the fact that we must not abstract our observations, our telemetry, and our measurement. I think we tend to lump those in together. And this is where we run into trouble, right? So you'll be familiar with this from network virtualization. The problem with network virtualization as an overlay, or the difficulty, is how do you see what the underlay is doing to see when you've got security, reliability, performance issues, because they're not as visible as they are in the next layer of the abstraction. This is true of almost every layer of abstraction. It's harder, if you want to provide a good quality service, you've actually got to see what the underlay is doing. So I think that we've got to be super careful that we don't lose sight by kind of automating away that knowledge of, and keeping it self-contained, what the underlying network is doing. And I think this will be the same when you're taking it up to the application level. So I want that as much as you do, but I think that we've got to be super careful that we trickle up somehow. And I don't know the right way to do this, right? But I think we've got to think, how do we trickle up that visibility at the lowest layer? Because that's where the attacks will be. That's where things will fail. That's where the security violations will be. And that's where the performance congestion will take place as well.
My take is the following. I mean, that's why I was talking about an infrastructure persona, a platform persona, and a developer persona, because the network will continue to be maintained and operated as a network infrastructure. To your point, Nick, we need to still understand if there is packet loss, if a router has a black hole and is losing communication to an entity, and so on. The question is going to be more, how do I troubleshoot? I mean, a lot of times right now when we monitor and troubleshoot networks, we think, what's the packet loss that I have in this network? What's the latency that I'm introducing, the jitter between my packets? But the question is it relevant? And in some cases, it's going to be extremely relevant. In some cases, it's not going to be relevant. So my prediction is that in this top-down mindset, what's going to happen is that instead of monitoring the network for packet loss, latency, and jitter, what we are going to monitor is why is this application right now not performing as expected? And how can you trace it to a packet loss because a fiber connector is dirty and the error rate is higher than average? In a way that when we start troubleshooting systems, we will do it top down, in a way that we have like the needle in a haystack search problem, right? The networking, you may have many problems in there. But if you have a starting point where you say, I have to create these critical applications running properly, then we'll have to have all the layers that you were mentioning, Nick, the telemetry at the packet level, understanding packet losses and so on, going one level up, understanding if DNS is taking too much to respond and so on, to fulfill the SLO and the application experience. But it's not that the top-down view of the problem simplifies the bottom layers. The bottom layers are still there. They have to be even more carefully architected than before because they have to be able to correlate the experience of what they are providing to the applications and the user and the customer experience. So completely agree with you. All the layers have to be there. The question is, how do we connect it in a way that from an operations point of view, there is a continuum?
I think it comes down to, again, going back to abstraction, but in this case, abstraction is defining the right SLA or the SLO, right? So we use this term called happy SLO internally, and what that means is if you have defined the right SLO, then when you deliver the SLO, your applications are generally happy. I'll give the example that I always use, Pere, going back to your point. Applications actually do not care about packet loss at all. They care about latency, but they do not care about packet loss at all, right? So exposing packet loss as either a telemetry or an SLO to an application is kind of meaningless. And at the same time, meeting that as an SLO is kind of meaningless for the applications, right? So it really comes down to, and especially given in the multi-cloud world, how complex the user experience and the application experiences are. SD-WAN running on multiple different physical networks as overlay. Unless we can define the right SLO for each of those applications, underlying applications, so that meeting those would guarantee that my top layer application is going to have the same behavior that it's designed to do. It is critically important. It is actually very difficult to do. It is not an easy task at all to define the happy SLOs.
I was helping a customer understand why an application was not performing. And they were telling me, look, I monitor my SLO, my 99% latency is increasing and means that the network is misbehaving. And we troubleshoot, and it was one of the pods in a Kubernetes cluster overflowed the disk because of logging. And at this point, it was slow. But the customer thought that it was a networking problem because the SLO was being violated. And we just had to essentially kill the pod, got restarted somewhere else with a clean disk, and problem solved. So when we start thinking, Vijoy, to your point, and Bikash, what you were saying about how do you take a top-down approach to troubleshooting, a lot of times the network is fine. I mean, we've been guilty by association for many years. And yeah.
No, man, the network is always a problem. We should all know that by now.
Yes, but it's much more complicated than just the network having a problem when you start thinking end-to-end transactions.
By the way, this is another place where, again, going back to why ML matters, looking into data from different layers to actually drive correlation is critically important, right? Drive the correlation between layer 3 and layer 1, L7 and L3 and L1, because oftentimes that's the fastest way to find the needle in the haystack. It's not easy to sort of just apply the human understanding of what's happening in each of the layer. So we need to do more of that, more fine-grained telemetry, but thankfully we have cloud to capture as much data as we want to. Vijoy, to your original question.
But I need to jump in here and keep us moving along. So you could call it the caboose on the train, or you could call it the headliner. In either case, our final set of predictions are going to come from Albert. Albert?
Hey, thanks, Tom. And thanks for inviting me back. I've got 3 predictions and a couple of simple stories and a hero or two to celebrate. And hopefully this will excite some good discussions. So, one prediction that I made in 2019, which I believe is durable and true and enabled by the work that we're doing as a community, is we're going to get way better at diversity and inclusion. And partly it's just because of the economics. The economics of cloud and of networking has really disaggregated, has been the force behind disaggregated elements where we can consume merchant silicon, we can get software from one place, hardware from another place, we can improve the supply chain and so forth. And really, once it's opened, then you can bring everything, people, all kinds of engineers to bear on solving the problem. And that's really been a fantastic thing, which I think we're part of making happen, but it's more true than ever, and it's accelerating. So we have a diverse and inclusive population in gender, in ethnicity, in engineering discipline, where people can take their UX skills, they can take their let's say photonics skills, they can take the full spectrum economic skills and bring it to bear on networking. And that's really a huge change when we were talking about closed and proprietary systems and a few companies controlling the entire ecosystem and innovation being stifled. So I think that was something I mentioned in 2019, and it's still true, and it's accelerating. And what it delivers is the rate of innovation is just picking up tremendously. So everything is innovating at every layer, again, down to the photons and the electrons and up to the service mesh that we were just discussing. It's really, really, really exciting. Second prediction. 3/4 of these people that I'm talking about, 3/4 of their hours are going to be spent in the early parts of the design life cycle. And when we talk about SDN, really, maybe we should talk more about software. The S in SDN, and really that is the essence of it, is getting the software right the first time, and not say patching and getting another release or something out in production, but getting it right the first time. And if you think about the life cycle of development, it starts with design, it goes to implementation, test, and scale test, and deployment, and then ultimately decom. So if you're one of these developers out there that I'm speaking to, then your time, 3/4 of your time, will be in that early part. It will be in the testing of your design and the validation of your design, the throwing everything you can at getting it right the first time. So on reflecting on who's a hero in this space, there's Margaret Hamilton from the NASA world that you may have noticed when Obama gave her a very significant award, and then there's been further kind of celebrations of her in YouTube, and you can read her papers and so on. In fact, I really do encourage you to go read her papers or watch a YouTube video of Margaret Hamilton, and don't stop when it gets mathy. Keep going, power through it. It's amazing. So her focus was safety, and that's, as networking, we really haven't talked about it yet, but it's our focus too. Bikash talked about the pandemic, right? And if you think about what the clouds and the 5G and the cellular and all that stuff is supporting, it's everything in work and life, right? It's going to school, it's this conference, it's hospitals, it's police, and so forth. It's completely about reliable and safe. And the reason I use the word safe and not reliable is it really is about human welfare, right? I mean, the work that our community does is completely fundamental to human welfare and human prosperity. So I think safety is the right word. And when you think about Margaret Hamilton, she was designing the software to bring the Apollo program to fruition and get astronauts to the moon, and they had this mantra of failure is not an option. And well, I mean, not many rockets were going up, and really a disaster was an issue, and so failure was not an option. I think it's a little bit different today, but still safety is the critical thing. So what she worked on were things like overload control, quick prototyping, formal methods, code generation, the kind of things that really, as engineers, we should be doing, and you will be doing if you're listening to this more and more every day than you were in the past of tweaking configs and things like this. So the third prediction is this will result in really, really great increases in velocity of what we're rolling out in terms of innovation, as well as safety, right? So, and it will mean that the engineers involved will spend their time on these things. Even though we've talked about the difficulty of troubleshooting, that's not where they're going to be spending their time, folks. So I show here, in the slides, 3 images of great engineers that are spending their time doing this stuff that I'm calling shift left. Again, if the dev lifecycle goes from the time runs left to right, then they're going to be spending their time on the left-hand side. So, first I show an image of a data scientist who's, running massive simulations all day long, wondering about, do we have enough fiber in Texas? And, what about the, potential weather event or what about a device failure? And this is happening in real time all day long on Azure, so that when those things do happen in Texas or elsewhere, we're okay, right? So that the hard work, the machine learning, and all that stuff happened in test. Second, I show a picture of another engineer who's doing code emulation at massive scale. So she's running the actual code in nested virtual machines at tremendous scale, so that unforeseen bugs will blow up in the simulator and not in production. So again, she's working on safety, and she's doing it in the life cycle. And third, I show a network engineer who's really, really focused on the verification part, the formal methods. And just like you can read the story about Margaret Hamilton and her, the 1201 error, the 1202 error that happened just as we were landing on the moon, and because of her overload control algorithms, we were safe. There's everyday examples from this engineer where I can tell you just the last week or so, line 42 of a complex migration had a bug in it that really a lot of great engineers looked at that migration script or migration process and did not find, but the formal methods with Z3 and all this fantastic theorem proving stuff underneath popped out, and then we fixed it before it happened in production. So again, the great thing about our community is it's opening and becoming more diverse and inclusive. We have much more focus on the software part. We haven't talked enough about software in this forum today. And third, it's producing real results where we're getting a safer result that we all need, because what we're building is so important for life and work in the world today.
Albert, I think I speak for the whole group when I say we really appreciate your dedication and commitment to diversity. It's such an important issue, and you lead by example, and it's very impressive. And this whole conversation has been about technology, but at the end of the day, technology is nothing more than about people, right? And how we organize people and what people do. And so I really enjoyed your comments. Bikash, I'll start with you, I'll end with you. Maybe you could react to Albert's predictions, and let's have a discussion.
Yeah, so on safety and shift left, completely with you, Albert. That has to be where we go. I do want to discuss a little bit about diversity and inclusion. Many of us are quite passionate about it. You have been. Networking needs to be sort of a reflection of society, and it's not. This panel is the best example of that. We are hardly the reflection of the society around us. It has to be solved where we have the next generation of engineers that are better reflection of society, right? And the part that I'm a little bit worried about, and this is where I would also love Nick's view, because Nick is right in the middle of this, and of course, Albert, your views, right? Even though more women go to college than men, the CS major population among women, actually women percentage of the population actually has gone down compared to 1990s. Even though they're doing more STEM, they're doing biology and not computer science. What do we do to actually turn this tide? Because if we want this panel to look different 5 years from now, we need those that are going to universities right now to have a different distribution than what is happening. Any thoughts there, Albert?
Yeah. Let me try to address that. One is at the let's say university level, I think we're okay. It's really 50-50 essentially, but in terms of gender, but not every place in the world, but in the U.S. and in particular, but where where you have to really make a difference and think about making a difference here is in hiring decisions, right? And an example that I'm sure you have, and I certainly have, is that if you believe that the problem is, say, formal verification and not BGP, then why look at a BGP job requirement? So look a little bit deeper, take a little bit bigger risk, and welcome that sort of diverse set of talent that we can offer, because the leadership skills, the technical skills are more computer science, more math, more general than just networking. And that's because things are open and we can change anything.
As the educator in the group, maybe just adding a couple of comments, just reinforcing what Albert said, that at the university level things are looking better. As there has been a massive increase in the number of students who choose and opt to do and study computer science at university in all forms, whether it's machine learning through to systems through to theory. We've seen not only a big increase, but also a much greater balance in gender. And so you are absolutely right. In the 7 or 8 years ago, it was looking worse than it was in the 1990s, but it's actually picked up quite a bit. We've seen numbers up to about 40% for our early picking computer science as a major at Stanford. But that number is still increasing. And so I think that that's a good sign. It takes a while for that to trickle through. But I think Albert is absolutely right that as we move away from being steeped in protocolry, that's all about interoperability, to software, we can be much broader in the expertise. We've all worked with people who didn't have a computer science background or a networking or a systems background who have turned out to be amazing.
So all that is very true. However, somebody still has to design the NPUs and the next networking ASIC, and less and less students are actually going for those specializations, and you kind of start seeing that in the industry, right? It's very hard to hire them when you want them, especially in networking, because they want to build the next TPU and not the next NPU necessarily. What do you do about that?
Being successful as a leader or a team player is hard to learn. I don't, there are skill sets that really don't require let's say deep networking, 5 years of experience on this and that protocol. I see the examples every day. And if I ask, say, one of my photonics engineers, at 10, if I have 10 pounds of work for you to do, is it 9 pounds of photonics and 1 pound of software? No, they say no, 9 pounds of software, 1 pound of photonics. So it just happens that things are software defined. We can change anything, and getting the software right is the hard part, in my point of view. Therefore, it's open.
And if I were to summarize things I heard: simplification, automation, abstraction, standardization, move towards software. But at the end of the day, as Albert pointed out quite eloquently, it's about people. And great people make great products, and great products make great companies. And so it's going to be an exciting time for networking. Thanks to everyone for engaging in a great discussion. Thanks to our audience for tuning in and listening. And we look forward to more. Have a great day, everyone.